So I am going to explain the concept of vectors. So vector algebra is very useful to analyze the concepts of some physical quantities which are having directions and all. So now I am going to before going to explain the concept of vectors. So first I am recalling the one physical quantity, that's called what is physical quantity. Simple analysis, physical quantity. So the meaning of quantity is the value or the property which should be quantified, that is called physical quantity. So let I have a substance, let it be a substance. This substance having a few of properties. Let example, it has height and breadth and something length. Similarly, due to this it has volume, that is length into breadth into height, and it is the color of this block is, let it be white, then color it has color, and it has some mass. Okay, and similarly it has density, that is mass by volume. Like that, whatever properties it has, those all are called, whatever the behavior it executed in nature. Okay, what the matter which what behavior it exists in nature, that is simply called property. So now these properties are, I am classifying these properties into two ways. So few of properties we can measure and few of properties we can't measure. So properties which are measurable, those are called physical quantities. Simple logic, the properties of material which should be quantified, which should be measurable, those quantities alone those properties alone we called physical quantities. Clear? So what about other, those properties which are not measurable, which we can't measurable? So those properties are simply called as properties. There is no other name for that. So simply so physical quantity means, now we understand the property of material which should be quantified, that is physical quantity. So length we can measure, so length is a physical quantity. We can measure how much amount of substance present in it matter, that is called mass. Thus so mass is a physical quantity. So like that, physical quantity means a property of material. Right, now we know about physical quantity. Now I am classifying these physical quantities into two types. So physical quantities into two type, one two. So what is first type? First type is called fundamental quantities, and second type is derived quantities. Fundamental and derived quantity, what is these two? So fundamental means the physical quantities whose measuring technique is independent on other measuring techniques. For example, the measuring technique of the physical quantity is adapted one, so that is, it's not adapted one, so that is unique measuring technique. For that, if any physical quantity having unique measuring technique, then that physical quantity is simply said to be fundamental physical quantity. Okay, so that measuring technique is doesn't depending on any other techniques. So those are base measuring techniques, those are called base measuring techniques. For example, distance between 2 points, let that we call length, breadth, height, displacement, distance, whatever it is. If we want to find how much path length having between 2 points, that is called a that process should be same, either distance, displacement, whatever it is, the measuring path length between 2 points, the way of measuring is same. So this measuring is unique, it is independent on other techniques. To measure these distances, we use some reference values, those are called one stick of length is 1 meter. Let this 1 meter length, no, it's a hand stick of one king. So actually past days one king used the hand stick at a particular length, with a particular length, that length we can treat it as 1 meter. Okay, it's a reference. So in olden days some scientists said you just follow this length as 1 meter. So nowadays we are following that. They initially they said this distance is treated as 1 meter. So now we are going to follow which, if it has in that much distance, then it is called 1 meter. So that is a reference one. So depending on reference one we are measuring. So that's why the physical quantities, so these type of physical quantities methods are independent on other quantities. Few of examples are mass, length, time, electric current, molarity, temperature, light intensity. So all these are simply called, all these are fundamental quantities. All these 7 are called fundamental quantities. These measuring techniques are independent on other quantities. Coming to other remaining physical quantity, whatever velocity, speed, distance, sorry not distance, speed, acceleration, force, torque, work, power. So we have etc. lot of physical quantities we have. All these are depending on other quantities. That's why these we can't call these quantities as fundamental quantities. Why? Because no, simple, see what is formula of velocity. Simple, velocity is simply I am saying rate of displacement. That's why displacement by time. So we have, for displacement we have one special technique, and for time has we have some special technique to measure. So depending on these two techniques we get the value of velocity, right? So that's why velocity is not a fundamental physical quantity. So velocity is called derived physical quantity. Coming to force, according to Newton's second law, simply F equal to ma, mass into acceleration. For measuring mass we have one measuring technique, and acceleration we have another measuring technique. Simply acceleration is simply velocity by time. Coming to velocity, it is dependent by displacement by time, whole divided by time. So how many times we are using measuring techniques, and how many different measuring techniques we are present in this formula. So F equal to ma. So that's why force is also depending on other physical quantities. That's why force is also a derived quantity. Okay, and I am explaining not only this. So coming to volume means length into breadth into height, right? See, in this example we are using same measuring technique for length, for breadth, for height. We are using same same measuring technique. Okay, but same measuring technique, but this same measuring technique can repeated 3 times, multiple times. Okay, if we repeat the same measuring technique, then also that physical quantity is called derived physical quantity. Clear? So fundamental quantity means we have unique measuring technique. That physical quantity has unique measuring technique, and it is independent on other quantities, and it can't be repeated. It cannot be, it shouldn't be repeated, it should not be repeated. Clear? So fundamental quantities are those. And coming to remaining derived quantities, may some other physical quantity measuring techniques involved, or same measuring technique will repeated multiple times, then also that physical quantity is simply called derived physical quantities. So depending on measuring technique, these physical quantities are classified into 2 types, right? Now I am again classifying physical quantities into again 2 types. Physical quantities, again I am classified into 2 types. What are those physical types? So 2 are vectors and scalars. Let it be vector, and next one is scalar. So what is vector, what is scalar? See, vector means physical quantity which has direction and magnitude. So few of physical quantities, coming to all physical quantities, few of physical quantities are depending on direction. Definitely those physical quantities has direction. So those which physical quantities has direction as well as magnitude, whatever, if it is physical quantity, mean what is physical quantity? So which property is measurable? So what is that meaning? We have to measure that physical quantity, right? We can measure that physical quantity. Whenever we are going to measure, definitely we will get values. That value is called magnitude. Okay, so whatever, either it is derived physical quantity or fundamental quantity or scalar or vector, whatever type of physical quantity it is, definitely it has magnitude. So don't worry about it has magnitude and all these things. Whatever, if it is physical quantity, definitely it has value. So definitely it is it has magnitude. But coming to direction, few of physical quantities only having direction. So the physical quantities which have direction or which depends on direction, those physical quantities alone called vectors. Coming to scalars which have only magnitude, so it not having direction. So this is magnitude plus direction. So physical quantity which has magnitude plus direction, then it is called vector. So these are vectors, physical quantities are vectors, and these are scalars. Right? This is a classification. This is classification. So now, so coming to scalars, calculation part is very easy. Not easy means we are whatever measuring, whatever calculation, but whatever mathematical tools we are using to solve the problems regularly, those mathematical techniques, by using those mathematical techniques we can solve the scalar quantities. So multiplication, addition, division, and subtraction, whatever type is, you can do as it is format. But coming to vectors, those are depending on direction. So while measuring physical quantities which having direction, so by that time we have to concentrate on with magnitude as well as direction, right? So what new direction it has, so or by applying that much force on any particular bodies, in which new direction, in which direction it turns out. Okay, so how much, with what value it is, with what acceleration it moves. For example, simple, so let it be a block of mass m. I am applying a force F. Then by applying this force, it gets some acceleration. Okay, it definitely gets some acceleration. So along this, due to this force, this body moves in which direction? Either this direction or this direction or this direction, on which direction it can trace. So we have to concentrate with value plus as well as direction. So we can't use, we shouldn't use general calculations for vector. So that's why to solve the vector components we are going to use vector algebra. That is one of mathematical tool which is used to analyze the concept of vector motion, right? So to analyze the vectors, we have two type of techniques to solve the vectors. Okay, to solve the vectors we have two types of techniques, that is analytical method and one more is graphical method. So analytical method and graphical method. What is analytical method? In analytical method, so we have numbers and symbols. In graphical method we have diagrams. So if vectors can solve by using diagrams, then that method is called graphical method. If by using numbers and symbols, if we solve that vectors by using numbers and symbols, then that method is called analytical method. Both are very easy, so don't bother about and don't confuse. So solving problematics, while solving the problematics, you just concentrate how we can apply, or which type of formula here we have to use. Just concentrate on little two or three special conditions, definitely you can easily understand these concepts of vectors. So don't bother about vectors. So now I am explaining the vectors concept, right? See, How can I represent vector? First, representation of vector. Representation of vector. This is very easy. Representation is also. So I can explain both the ways. I am explaining both the ways. So that is graphical method and analytical. Simple. See. So we have three-dimensional coordinate geometry. That this axis is x-axis and this axis is y-axis. Okay, I can draw in another way. See, I am drawing a cuboid. So we have three axes, x-axis, y-axis, z-axis. So this is three-dimensional geometry. So three-dimensional geometry is useful to analyze the spatial motion of the body also. So that's why. Let a particle, initially a particle is at a distance of here. If the particle is here, this is the position of particle. So now I want to find the position of this particle. Position means how far the particle from the reference. So I am taking this reference as origin. So let it be origin. O is origin. Origin means that is reference point. So let that origin is 0, 0, 0. So this is origin. And now to analyze this concept, if we want to find the position of this point, so how far this point from the origin, this is called position of particle. So position of particle is also a vector. So vector means simply a straight line having arrow. This is a representation of vector. This is completely diagram. So this is graphical method. So let from here to here, this is magnitude and it is head part. So we call this is head part and this we called tail part. Okay, this is graphical method representation. So if we have a straight line with arrow, that is representation of vector in graphical method. Okay, so what about analytical method? Let this point has a distance of x units on x-axis, y units on y-axis, z units on z-axis, and the point is O is origin 0, 0, 0. Okay, so by using these coordinates, if we represent the vector, then that is called representation of analytical representation of the vector. See how it is. To analyze that, now I am saying let I cap and j cap and k cap are direction vectors of x, y, z respectively. What's this meaning? So if for example we have 3 I cap value, let it be 3 I cap. What the meaning is, it 3 units on x-axis. See, if we have 3 I cap, this value 3 belongs to x-axis. If we see value as minus 4 j cap, then this value of 4 belongs to negative y-axis. So j represents y-axis, minus j cap represent negative y-axis. If like that, if we have something into k cap, let 2 into k cap, then this value 2 belongs to k cap. K cap means which axis? Z axis. So this is negative y axis. That's the meaning. So I cap, j cap, k cap represents the direction of axis. So that is, if we have I cap, that belongs to x axis. If we have minus I cap, that belongs to negative x axis. If we have j cap, that belongs to positive y axis. If we have minus j cap, that belongs to negative y axis. If we have k cap, that belongs to positive k cap. So positive z axis. If we have minus k cap, that belongs to negative z axis. All these are called direction vectors of x, y, z respectively. Now I am saying, see this point, position of the particle from the diagram. Just see this diagram alone. See, one point is here, right? So this is point, let this point is A, and one more point is origin. One is x, y, z, and one more point is 0, 0, 0. So now I am writing vector of OA bar. Okay, in analytical method. How can I write? See. See, one point is 0, 0, 0, and the other point is x, y, z. So straight line having arrow, this is graphical method, so that name is OA. So I am giving vector name as OA bar. This is name. Okay, OA bar, just I am giving a name. Bar means it represents a vector. Simple. So in analytical method, OA bar is equal to how much distance traveled on x-axis. On x-axis, it is at a distance of x, and this is 0. X minus 0, that become x minus 0, which is along I cap. And similarly, it makes y minus 0 distance on y-axis, and it makes z minus 0 distance on z-axis. So all these three did by one particle only. So that's why OA bar is equal to simply x units distance on I cap plus y units distance on j cap plus z units distance on k cap. So here we have values, x, y, z are values, and I, j, k are symbols. So the values along with symbols, if we represent any vector with values with symbols, then this method is called analytical method representation. So this is analytical method representation. Clear. So now I am going to explain briefly in analytical method also. I am giving one more example. See, for example, if someone has doubt, first I am explaining in 2D coordinate, 2D geometry. This is easy to understand. If we have x-axis, y-axis, 2 points alone, and I am having here one point, here and more point. Let this is x1 comma y1, and this is x2 comma y2. What is the meaning of x1 y1? So this is origin, right? If you draw a perpendicular, foot of perpendicular on x-axis from initial point A, then how much distance this foot of perpendicular, how much distance it has, the foot of perpendicular has from the origin, that is x1. Similarly, if you draw a foot of perpendicular on y-axis, this foot of perpendicular has how far from origin, that representation y1. Similarly, for second point, this foot of perpendicular is, the distance is x2, and this distance is y1, y2. Okay. Now if I want to measure the distance between these two, so this 2 means this particle moves in two coordinates. Two coordinates means every time to time, the coordinate values, the values of this particle is varying along x and y axis, right? Time to time x value is changing, similarly y value is also changing. That's why this motion, this particle motion is simply said to be two dimensional motion. So now what my question is, what how much distance it traveled on x-axis? This is what I want. So see, x2 means from origin to this point is x2, and x1 means from origin to this point is x1, right? So now how much distance it travels on x-axis, that is this. I want this distance. That distance is simply exactly equal to x2 minus x1, right? So this particle makes x2 minus x1 distance on I cap, and similarly on y axis. So from origin to this point the distance is y1, and from origin to this point is y2. So now I want this distance from here to here. This distance is nothing but y2 minus y1, right? So this particle makes x2 minus x1 distance along I cap, along x axis, as well as y2 minus y1 distance along j cap. So now the particle displacement vector is simply, I am given naming as starts from A and at B, and this is vector, that's why I am representing with the bar. So this is simply name. So now that vector representation AB bar is simply x2 minus x1 I cap plus y2 minus y1 j cap. Why I given plus? So it is it traveled along both the axes at a time. So along x axis plus along y axis. So this is for 2D geometry. If this particle makes three dimensional motion, so three dimensional motion means each and every point has three coordinates, that is x1 comma y1 comma z1, and one more coordinate is x2 comma y2 comma z2, right? So now I want to express this vector format. So this is graphical method, and this name is A and B, and the name of this vector is AB bar simply, and this AB bar, this is graphical method, okay? This is now analytical method is simply x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. This is what representation of analytical representation of the vector. See, just do one example. So if the particle travels from 3 comma 2 comma 4 to 5 comma 6 comma 7, then find displacement vector. I am drawing analytical method, in analytical method. So AB bar equal to, simple, let this is x1, this is y1, this is z1, and let this is x2, y2, z2. Just compare these values. What is x2 minus x1? 5 minus 3 I cap plus 6 minus 2 j cap plus 7 minus 4 k cap. So then AB bar, simply AB bar is equal to 5 minus 3 2y cap plus 6 minus 2 4j cap plus 7 minus 4, that is simply 3k cap. So this is the vector representation of that displacement. Okay. So now we know that how we are going to represent vector, and all these concepts we know now. See, So now, as said before, vector has both magnitude and direction. Okay, fine. Now I want to find what is the magnitude of, how we can find the magnitude of vector. Now I am going to explain the concept of magnitude of vector. So first I explained representation of vector, so that is over. So now I am finding magnitude of vector. So magnitude of vector, first in graphical method. What is graphical method? If it is initial point A and it is B, final point B, then the length of chord between A and B is nothing but, so this is AB bar, vector AB bar representation, this is graphical method. How much length it has, the chord length, this represents magnitude. Okay, so magnitude means nothing but length of chord. This is called magnitude. How we can get in analytical method? So coming to analytical method. See, in analytical method, magnitude is nothing, what we said in graphical method, length of chord. Length means distance between 2 points, right? So distance between, in analytical method, distance between initial and final positions of a vector given vector is nothing but magnitude of that vector. So if you find distance between 2 points, that distance is nothing but magnitude of that vector. Then how can we find this distance between 2 points? Let's see. See, so this is also I am explaining from 2D geometry first. So this is two-dimensional coordinate system. Let this is y and this is x, and if the points are this and this, let this is vector. So from here to here, this is vector. We want to find distance between these two, and this coordinates, this coordinate is x1 comma y1, and this is x2 comma y2. What is the meaning of x1 comma y1 here? So is nothing but, see, x1 means from origin how much distance it has, the foot of perpendicular on x-axis has how much distance, this is nothing but x1, so this is x1, and for this point x coordinate value is, this is, so foot of perpendicular from that point on x-axis is at a distance x2 from the origin, so that is coordinate of x2 of this point B. So let this point A and this point B, and A point x coordinate is x1 and B point x coordinate is x2. Similarly, A point y coordinate is y1 and B point y coordinate is y2. Okay, now I want to find the distance between them. How can I get this distance? So very simple. So I don't know to find this value. So that's why what I did know, I know the distance between, horizontal distance between these two. That is nothing but this. That is, what's the value of that? x2 minus x1, very good. And similarly I know this distance also. Why? Because this distance I know. So the distance between these two is simply y2 minus y1. So this is, these two are parallel lines, that's why this is also nothing but y2 minus y1. Right? Now I know these 2 points. Now this is converted as right angle triangle, right? In right angle triangle, we want this vector value length of this chord. Let this is what's the name, AB, right? So that value is, let this is AB, and this is x2 minus x1, and this is y2 minus y1. So then AB, we want hypotenuse square equal to side square plus side square, that is x2 minus x1 whole square plus y2 minus y1 whole square. So then simple AB equal to root over x2 minus x1 whole square plus y2 minus y1 whole square. This is distance between 2 points formula. So this gives the length of chord in two-dimensional geometry. So if with this point, this AB, right? So AB bar is vector. So don't confuse. AB bar is vector representation. If we draw magnitude representation is mod of AB bar, or simply write as AB. If you don't give bar, then that belongs to value. If you give bar, that vector has along with value direction also it has. Okay, fine. So this is coming to magnitude for two-dimensional geometry. But every particle has moving in space, right? So definitely it has three coordinates. So then if point x1 comma y1 comma z1, that is one first point, and let the second point is x2 comma y2 comma z2, then the distance between 2 points is the becomes magnitude. That magnitude AB is equal to root over x2 minus x1 whole square plus y2 minus y1 whole square. This already solved before. Similarly, we have extra coordinate, that is z2 minus z1 whole square. That's it. This is magnitude formula. So what this is AB magnitude. What is AB bar for these 2 points? AB bar is simply vector, that is final coordinate minus initial coordinate along I cap direction plus y2 minus y1 along j cap direction plus z2 minus z1 along k cap direction. See, this is the difference between AB bar and AB. AB bar means it has directions also. AB means only magnitude, there is no directions. So it gives a value. AB is completely value. AB bar is value plus direction. Along with values we have direction. So that this is vector, this is value, magnitude. Okay, fine. See, you just don't confuse. Simple. No need to. So to find the magnitude of vector, we don't want points alone. Why? Because what term we have in with multiple of I cap, that is x2 minus xy, and with the j cap y2 minus y1, and with the k cap we have z2 minus z1. Simply magnitude means root over the term along with the I cap whole square plus the term along with j cap whole square plus the term along with k cap whole square, simply. So which means, if let it example, if we have AB bar is 3I cap plus 4j cap minus 2k cap. So here you just compare, all vectors has plus symbols only actually. So 3I cap plus 4j cap plus minus 2k cap. You just convert like this. Now I want to find magnitude, that is AB, that is equal to root over what term we have in front of I, that is 3. So 3 whole square plus for j cap 4 whole square plus minus 2 whole square. This becomes simply root over 9 plus 16 plus 4, 29, root 29 units. Why I given units? So physical quantity has units, right? So all vectors are physical quantities only. So definitely whenever we finding the value, we have to give symbol unit. Okay, so this is about magnitude, or finding magnitude values. So I'll give one more example. Try to solve this. The given vector, let a bar is vector. So naming again, we can give naming as our wish. This is our wish. Naming is completely in our hand. You can give in any way, no problem. That is naming simple. But if it is vector, you just draw arrow on the top of that letter. Okay, so if a bar, let a bar is 2 I cap minus 3 j cap plus k cap. Then I want to find magnitude a bar. Magnitude of a bar means modulus of a bar, or we can represent with a. So why I wrote modulus? Modulus means if we get any negative value, that becomes a plus. That's a symbol of magnitude. Anyway, we don't get magnitude as negative. Why? Because we know. So magnitude means square of each terms. When we have negative value, square of that negative value become positive. So we won't get negative magnitude. So mod of a bar, it's one of representation, or simply you can write as a. That value become root over simple 2 whole square plus, don't take minus 3, so don't give 2 square minus 3 square, don't write like that, this is wrong. So if you consider 2 square, here we have minus symbol, that is minus 3 square plus 1 square. If you solve like this question, this procedure is wrong. So why? Because I said the representation of vector, in representation of vector, so we have three coordinates, that is x coordinate plus y coordinate plus z coordinates, right? So you just imagine this vector as 2i cap plus minus 3 of j cap plus k cap. So then that value is 2 square plus minus 3 whole square plus 1 square. So this is become simple 4 plus minus 3 whole square become 9 plus 1 square 1. 4 plus 9 13 14 root over 14 units. Clear? This is what magnitude of the vector. So in graphical method directly they will give as a simple is 3 units. So what is the meaning of 3 units means? They already solved the distance between these 2 points, right? That they given as 3. So no need to find magnitude. This value itself magnitude. Okay. So this is measuring this is measuring technique to find magnitude of the given vector. Okay, fine. Next direction. See, next direction of the vector. What is direction? Simple. First I am explaining about in graphical method. See, generally in our earth we have 4 direction, that is north, south, east, west, right? So wherever vector starts, at this tail part of vector you just consider these 4, north to south to east to west. If vector starts like this, you just consider north south east like this. If it is like this, you just consider here north south east west. So with this, for example, I am considering my vector is in this direction and it makes an angle of theta to east direction. The angle made by this vector with a reference, this theta gives the direction of vector. See, let this vector name is a bar. Now how can we say the direction of this a bar? So how can we say? So a bar makes an angle theta with north of east. What's the meaning of north of east? North of east means east to north side. East to north side. Okay, so that is the meaning. So next see one more example. See if the vector is like this. What I said, just imagine here directions. North, so sorry, this is north, this is south, this is east, this is west. News, north, east, west, south, news. Okay, n phase, n symbol model, news, news like this. You have to measure like this: north, east, west, south, news. Okay, you just follow like that, then you won't forget the directions of earth. Okay, fine, let this name is b bar, and this b bar is makes an angle with south as something like alpha. So alpha means the 30 degree, 40 degree, 45 degree, like that let it be alpha. And now how can we say b bar makes an angle alpha with, so this vector belongs to south and west, so third coordinate, right? So you have to write as alpha makes with west of south. So what is the meaning? It makes an alpha from south to west. So depending on direction, so for example if vector is like this, definitely it belongs to second coordinate. Second coordinate means what are north west. So if it makes an angle theta with north, then we can say this vector makes an angle theta with west of north. If the vector in fourth coordinate, then this vector belongs to 2, that is east south. So depending on making angle, you can give the you can address that direction. Okay, so like this, west of south means south to west. Okay, and then you just try it. Let this name is x bar, name of vector, and this is the direction given, that is east, and it makes an angle theta. So now tell me what's the direction of this vector x bar. So good, same check, you just check whether it is right or wrong. So now I am telling this direction. So x bar makes an angle theta, x bar makes an angle theta with, so this belongs to fourth coordinate, right? So east and south, right? Just write theta with south of east. So south of east means east towards south, that's the meaning, south of east. Good. Okay, so in graphical method angle gives the direction. Coming to analytical method, what gives the direction? Analytical method, in analytical method unit vector gives the direction. Who gives ma? Unit vector. What is unit vector? Okay, what is unit vector means name itself, it has the meaning. See what is unit vector. Unit vector gives the direction, so that's why we called unit vector is direction vector also. Unit vector or direction vector, both we can call them, no problem. Unit means magnitude of that vector is magnitude So value of that vector, magnitude of vector is 1, then that is called unit vector. So I cap, j cap, k cap are unit vectors of x comma y comma z respectively. So what's the meaning? Mod of I cap, magnitude value, mod of j cap, magnitude value of j, mod of k cap, all these values are 1. So these vectors has magnitude 1, but these are used to used for representing the direction. So to represent the direction. So not only I cap, j cap, k cap, for each and every vector has its own direction, right? Vector itself, it has direction. So whatever direction we have, so we know that no, see some vectors in this direction is not along x, not along y, not along z. So this is one different direction. For this direction also we have some different vector. Let that unit vector is n cap. So how we can find this direction vector? Okay, the formula for finding direction vector is, if a bar is a vector, then a cap, if we have symbol of cap, then that is unit vector, that magnitude is 1, so this is direction vector. If we want a cap, that a cap value exactly equal to a bar by mod a bar. So if we want direction vector, so you just divide that vector with its magnitude, with that magnitude. Divide a vector with their magnitude, with that magnitude, then we get direction vector of that vector. So a cap is equal to a bar by mod a bar. Mod a bar is nothing but a. So a cap is equal to simply a bar by a. Then that is called unit vector. This a cap is called unit vector. Sir, I said, how can you say, sir, how can you get this formula? How I know whether this is right or wrong? Sir, if you have any doubt, just check with some examples. Okay, now I am going to check with one example. See whether it is right or wrong. See, let a bar value is 3i cap plus 2j cap minus k cap. I want to find the direction of this vector a cap. I want. So what I said, direction vector means that magnitude become 1. I know this condition. If magnitude of vector is 1, then that vector represents the direction. So I want to find this a cap direction. So a cap direction is, what formula I given, a cap equal to a bar by mod a bar, right? So first we have to find mod a bar. Mod a bar is nothing but a. We know to find the magnitude of vector. So a equal to magnitude of this, the term before the I is 3 whole square plus 2 whole square plus minus 1 whole square. That become 3 square 9 plus 4 9 plus 4 13, 13 plus 1, that become 14 root 14 units. This is magnitude. Now you just substitute in a cap equal to a bar by mod a bar. A bar is simply 3i cap plus 2j cap minus k cap, and whole divided by root over 14, right? See, which is 3 by root 14 I cap plus 2 by root 14 j cap, simply minus 1 by root 14 k cap. So this is direction vector. If you have doubt, check with unit magnitude format. Just find mod a cap. Find mod a cap. So mod a cap is what the term we have in front of I, that is 3 by root 14 whole square. 3 by root 14 whole square plus 2 by root 14 whole square plus minus 1 by root 14 whole square. So this value become root over 3 square become 9, root 14 square become 14 plus 2 square become 4, root 14 become 14 plus minus 1 whole square is 1, and root 14 whole square is 14. Just that is root over 14 by 14, that value become 1. So we get unit magnitude. So direction vector formula, unit vector formula is simply, if a cap is unit vector, then that vector format is, so the unit direction vector formula is a cap equal to a bar by mod a bar. So mod a bar we can represent with a also. So this is what formula. So what is this direction vector? What is this direction vector? Simple. There is no special case of direction vector. See, for example, let it be origin 0 comma 0 comma 0, and we have point here, that is 2 comma 3 comma 5. So this is vector, right? This vector value is simply 2i cap plus 3j cap plus 5k cap. This is vector. I want the direction of vector. Direction means it is along this direction. This is, let this name is a bar. Okay, this is a bar. So this vector lies in this direction. So this direction unit vector is a cap. So a cap gives the direction of this. So to find this a cap direction vector, we got that value. So if particle is at a distance of r, so let it be r, then this is r cap direction. So if it r bar is vector, then r cap is direction vector. So r bar means it is moving from here to here. This is starting point, this is ending point. That is the meaning of direction vector. If the direction vector is along this direction, particle starts here, ends at here. That's the meaning. Clear? So this is about direction vectors. So in next class we can discuss about types of vectors and addition subtraction of vectors. Okay, thank you. We'll see you in next video.